So the presentation is anything but short. I'm going to try to stick to the 15 minutes that I was allotted, but I have 68 slides. At a previous presentation that I made, I think this was meant pejoratively, but somebody called my presentation, or me, as being a hummingbird and crack. This will be my attempt. That's going to be the theme. All right, so in terms of climate reporting in the press, I see it in four main flavors. The first flavor is the denial, that it doesn't exist. Climate change doesn't happen, and this is Inhofe. He's the sort of standard bearer of this thing, and people that report. And then this is the much more, and through all of these, there's usually a thread. There's usually in that article, there's a graph which shows ppm, parts per million of carbon dioxide in the environment. But these are the four main flavors. So deniers, then there are mega events. Some ice shelf is breaking off somewhere. Some glacier that used to exist no longer exists. The third kind is species protection. Here is the Florida governor who's actually up for re-election against Charlie Crist, this time as a Democrat, who's releasing a turtle into the sea. And finally, there is the hopeful stories, which is how good renewables are doing in Germany, or something like that. These are all fairly recent stories. But I think all of them miss the point. The point about the environment, and therefore I think reporting about the environment, is all about consumption and not about supply, not about these things make for iconic touch points and are in many cases hopeful and sometimes not so hopeful stories. But I think they're not the main story, and I think all around, and the environmental movement also in particular, it's a great tragedy, but we're all barking up the wrong tree here. And I'll try to present some data to substantiate that. I'm going to start with a very few quick slides about public transportation and climate adaptation. This is the big irony of it, because I think public transportation is by far the most effective way of halting climate change, of healing the environment. It's very, very ironic. People don't think of it as such. People mainly think of it as steel gnashing against steel and creating sparks and something fairly brutal, but it's actually very friendly to the earth. But it's also a great irony that we are, in many cases, especially in the northeastern states, the unofficial stormwater conveyance systems. So when the city's system gets overwhelmed, water flows in the subway tubes. This is what happened with us in Sandy. This is on Metro North Railroad. I find this is another, again, it's an entrance to one of our tunnels, and I find the big irony that little solar PV panel is sticking out of the waters as they're rushing in. This is New York. It's a tough audience. That guy in the white shirt, he is completely oblivious of that wall of water in front of him. He's wondering where his train is, and he's getting mad, and I'm sure he's cursing the MTA. And you guys have all seen renderings like this. These are sort of futuristic. This is, I believe, a 2.5 feet rise in sea levels, which is very much now within the realm of possibility. And this is what Lower Manhattan is going to look like if nothing were done about it. And so there's a very good assumption. I mean, this may well be the way to take the subway in the future. So now I'm going to step back a little bit, and I'm going to look at some data from the top down and from the ground up. And I'm going to start with from the top down. And it's a pity that the lady from Chicago left, because I'm going to challenge two notions that she presented. One was that in Chicago buildings, and I feel badly challenging it in her absence, one was that in Chicago buildings emit 71% or whatever that number was, and so we should do something about it. That's actually not true. Chicago will get greener if the building emissions go from 70 to 80% to 90%, et cetera, and I'll tell you why. And secondly, transportation. The notion that transportation is the cause of, and I know this is roughly true for many places, this is true for the nation, is responsible for 29% of all emissions. This is EPA's number, and depending on how generous you're feeling, it's a misstatement or a lie. This is because they take the refining and the transportation of the fuel energy number and put it under industry, which is incorrect, because usually you put under the industry category embodied energy, such as, say, what the energy was spent in making the car, because that can be amortized over 60,000 miles, 200,000 miles, whatever. But in terms of something that has a one-to-one relationship with the emission, i.e. the fuel, if you incorporate the refining and the transportation and all the what's called the wells to wheels, there is a 50% overage. It goes from 29% to 43%. So 43% of all US emissions comes from transportation. And the EPA number is 29. We are pretending it's about a quarter of the problem, and it's really half the problem. There is nothing else that is this big. And we don't even, so the first thing you have to do is account for it correctly. And accounting makes a difference. Very often you have to do nothing else, just stating it as it is, does it. This is now looking at 4 countries. We don't know how much their absolute consumption numbers are. This is from the World Resources Institute. China and India consume about a tenth of their energy in transportation, 12%, 10%. Germany, which is on the high side of the OECD, consumes about a quarter of its energy in transportation, and the US, as I said, consumes about half. And Germany, by the way, is on, if this were Japan or if this was the UK, it would be more like 22%. I don't know if that's UK with Scotland or without, I don't know. But Germany has higher life expectancy, lower infant mortality. On all human development indices, it's ahead of the US. It's a very, very car-friendly culture. It has more cars per driving age adult. Actually, all of Europe has more cars per driving age adult than the US does. They just don't drive them so much. And this is somewhat true as China and India come online as to what you see your car's main utility as. If it's something to show off to your neighbors, the car is something you want to bring out every Saturday afternoon and wash while everybody else is watching. That's great. That's a great use for a car. You just should not be driving it as much. Now, we didn't know they all look relative. I just said what fraction of each society was transportation. This is what the numbers are for energy consumption. So the US is about 285 million BTUs per person per annum. Germany, with much higher levels of human development, is about half the US. So they're doing all this on half the energy. China is about a half of Germany, and India is about a third of China, and India and China both are growing at a fairly rapid rate. Now, you might say, Germany is a small country. It really doesn't matter. You couldn't do this in the US. That's not true. What the potato farmer in Idaho does, the size of the truck that he drives, or in Morris, Minnesota, it does not matter. This battle or war is won or lost every morning at 8:30 or 9 on the arterials outside Atlanta, outside Phoenix. That's where the difference is being made, where people are clocking up VMT like crazy. That's where this whole environmental battle is being lost. Now, for that 285 national number, I looked at the 3 most populous states. So New York, we have 185, which is incredibly close to the German number. Germany was, I think, 178 or something like that. This is BTUs per person per annum. BTU itself, there's a little sidebar joke that I have. BTU stands for British Thermal Units. The British don't use it anymore, but we continue. For California is a surprisingly low, pretty close to Germany, 209 million BTUs per person per annum. But remember, the national average was about 300, so someone has to do the hard work. And Texas is about 500 million BTUs, which does not include any of your biking. And Texas, these are the 3 most populous states that I sampled. It's not that Wyoming, I think, is actually about a billion BTUs, close to 975 or something million BTUs per person per annum. And there is nuances in this. Some of that is fuel that might be refined in Wyoming but might be used somewhere else, etc. But by and large, what you can really, the donkey you can pin the tail onto is land use and transportation. And there's nothing congenitally wrong with Americans. So in this case of the 5 boroughs of New York City, which is where I come from, that number is half of Germany. It's 88.5 million BTUs per person per annum. People are walking a whole lot more, biking, using public transportation, just not driving as much. So I looked at this from the top down, 4 countries, the world, etc. Now let's look at it from the bottom up. So I'll take 1 million square foot of commercial office space like this, commercial carpet, air conditioning, etc. But the only difference is one is in an office park in Albany, because I'm from New York, and the other is a building in Midtown Manhattan. A mechanical engineering colleague of mine called Dan Knoll and I, we ran this through a now defunct energy software, free software from DOE called eQuest. And this is, of course, the building, the tall building in Manhattan, and that's the office park in Albany. And turns out on a per square foot basis, normalized to per square foot, the buildings look very similar. This is energy for lighting, this is energy for air conditioning, the blue is energy for vertical circulation. So because the office park on your right has more escalators and elevators, it's kind of a little bit more blue. But on top of that, once you superimpose the transportation energy, this is what the graph begins to look like. So how many of you have heard of LEED, green building? So LEED is all focused here, and all the action is there. And this, by the way, is a very unflattering picture for public transportation because it takes a diesel bus, I don't know if you can read that, doing 4 miles per gallon with 20 passengers on board. If this was like the blue line coming in from O'Hare, that red would be that much. So really, and this is normalized to a per square foot basis. Unbeknownst to Dan and myself, there were people doing similar analysis, the citation is there at the bottom, who were normalizing the same thing on a per person, on a per user basis. And again, the graphs are almost identical. This is the embodied energy of the building, this is the operational energy of the building, and this is the transportation implication. You can build the greenest building, the LEED, platinum, super duper, everything, and then have everybody drive a car to it back and forth, and you're wasting your time. Okay, so now a little bit about this notion of the electric vehicle. And I will ask you at the end of it what you think I think about the electric vehicle. Okay, so this is a map of the US county by county. This was the last time gas hit $4 a gallon. And this is the fraction of the household income that is spent on gas. And gray is less, and yellow is more. Now, if you saw this thing, and you could come to one of two conclusions. You could either, it could be a denominator conclusion or a numerator conclusion. You could either think that households on the coasts make more money, and therefore, as a fraction of their household income, spend less on gas. And if you thought that, you would be right. You could also think that gas, numerator, gas is more expensive in the middle of the country, and therefore households in the middle spend a larger fraction of their income on gas. If you thought that, you would be wrong, because this is the price of gas, and gas is the cheapest where people are spending the highest fraction of their family income on it. This is called the rebound effect. This happens again and again. This is what happened. Those of you that studied the internet usage went this way. As something gets cheaper, people use more of it. Now, thinking of, on a per cost per mile basis, doubling the efficiency of an engine, of a car engine, and halving the price of gas has an identical effect. Basically, it halves the per mile cost, right? So in some sense, the people with the lowest energy cost have the most efficient engine, if you will, right? Because they are per mile cost, at least purely on a gas basis. They might be driving old, very old cars, but at least on a per mile basis, their engine is the most efficient because it's the cheapest. I have just 3 minutes left, and I have still 30 slides to do. So I won't dwell on this very much, but the point is 50 mile per gallon or 100 mile per gallon miracle engine is not going to solve our problem, because we are going to take much of that efficiency and, if I may use some French, piss it away. Okay, so public transportation and public health. I actually wanted to show you a bit of Who Framed Roger Rabbit. I don't know if you remember the movies, but I always show this to show Jessica Rabbit here. The movie Who Framed Roger Rabbit was basically on a sort of based on Los Angeles's taking down its public transportation system and replacing it with freeways. This is when the movie was made, or the movie is set. This is vehicle miles traveled, and this is vehicle miles traveled per capita. I don't know how well you can see this. I introduced another line here. This is when the movie was made. So this is when the movie is set, this is when the movie is made, and this is right about now, when VMT is leveling out. And VMT is leveling out a little bit only because you cannot drive two cars at the same time. No person can. But Google is trying to solve that problem as well. So very soon we will have the capacity to drive two cars at the same time, or maybe three. And I'm sure we'll figure out a way to do it. But the point of this graph was, if you look at that last bit of the geometry, it maps very closely the obesity rate during the same time. So I cannot prove causality, but the correlation is very high. This is the map of the US from not very long ago, 1990. Pale blue is under, this is CDC definition of obesity, pale blue is under 10%, and the darker blue is 10 to 15%. In 1999, this is what it looks like. In 2008, this is what it looks like. And this is what it looks like now. We are driving more and more and more. And this is actually a very good infographic, and it absolutely correlates the availability of bike, ped, bicycle, pedestrian, and public transportation, which are, by the way, all three linked. You can't have a bike, ped culture without good public transportation because it needs density. In Dallas, you are one of 6 people who are biking because it's essentially hard to bike. And this is sort of an international context. This is kind of, again, the OECD countries and looking at the national obesity rate and walking, biking, and subway usage. So it's, again and again, this is kind of borne out that you should not be doing this only for the planet, but you should be doing it for yourself, for your children, for your families, because this is just a healthier way to go. So what is it worth, and how can we take this warm and fuzzy feeling and turn it into dollars? And if we can turn it into dollars, then maybe a company like the MTA can get more money, can bond against it, can build a new subway line. In Phoenix, Arizona, they might be able to become a transit city. Los Angeles, San Diego might all be able to invest more money if we can establish a value for this. So we did this by looking at data that is available, census data and that kind of thing. We did a fairly elaborate model that Booz Allen Hamilton did for us from an APTA model that we had. And we measured 3 things. One is called land use factor, mode shift, and congestion relief. And all of these 3 things you can get data on. And we did a credit and a debit side. So our own debit side was emissions produced by us, and then through those 3 factors, the emissions that we displaced. And it turns out for the MTA in New York, we emit about 2 million metric tons of greenhouse gases, and I have 0 minutes left, and 17 million metric tons is avoided. So I'm going to rush through this, but basically we generate about $500 million of value that currently the system does not recognize as a value and does not compensate us for it. And if you could do this, if you could do this nationally, public transportation, rather than being a handout to the marginalized of the world, would actually be something that could be used. You can find a lot of this information at mta.info/sustainability. And I just want to very, very quickly go out on this notion that that this can only happen in New York. So this is Cincinnati, the turn of the last century. They built a full subway system, never used it, it never finished. So I reeled the camera back to New York when Cincinnati stopped building. That was New York then, and this is the same place now. So any of these questions, and this is again Queens Boulevard when it was built, and today. And this is Los Angeles, but any of these questions that say it can only happen in New York, I turn into, does transit beget density, or does density beget transit? So do you need to be a dense place in order to have transit, or will place densify once you put transit in? And this is Los Angeles, Hollywood and Vine. They put a metro system in there. That's the entrance to the metro. The place densifies. This is Portland, Oregon. And again, we see that once a system is put in, people actually start living around it. So as societies develop and industrialize, their energy needs rise. Transportation emerges as a major consumer of energy. The automotive-based suburban, with the corollary of suburban sprawl, is unsustainable. Sustainable urban growth has to embrace mass transit and support density. Carpooling, etc., can work only with adequate transit support, and designing the right carbon constraint system. So putting a value on the carbon that we save will make this work. And I swear, last 3-4 slides. This is a picture of utopia that was painted in the 50s. This is house, boat, car, yard, and this is the world it created. And we are fighting that picture with this picture. That's the wrong picture to be fighting it with. We have to fight it with a picture like this, of density, of beauty. This is Lisbon. People say it only works in Europe, doesn't work in America. So then I say it does work in America, and it works in one of the boroughs of New York, which is Queens. except Queens is not photogenic at all. So I do this. But anyway, this is Queens. This is Jackson Heights, where the 1% live, as well as the 99% live, where there are industrial jobs still left, and people live cheek by jowl, all on the back of good public transportation system. This is just a shameless plug. This is my blog. It's called Taking the Car Out of Carbon. I also tweet at Projjal, and that's my presentation.